Hi everyone. This last video we will look at some examples. Now one of the reasons e is called when you have an exponential function involving e as the base is natural exponential function is because a lot of the natural growths and natural decays happen in that form. So e, just like you whenever you see pi you think there's a circle involved. When you see e you think there's a natural growth or decay that is being involved. Now, one of the models for the spread of an infectious disease in a city of population 10,000 people is given by the following. Vt is 10,000 over 5 plus 1245 e to the negative 0.97t, where Vt is how many people who have contracted the disease. Part A says how many people are there initially. Oftentimes when we say initially in these models, right, it means when all the parameters are zero. When all the variables are zero. So when t equals 0, v0 would be 10,000 over 5 plus 1245 e to the 0, right? Because 0 times 0.97 negative is also 0. But e to the 0 is just 1. So this is 10,000 over 1250, which is 8. So this particular infectious disease started with 8 people being infected initially. Then it says how many infected people after 1, 2, 3 days. So that would be V1, that's 10,000 over 5 plus 1245 e to the negative 0.97. V2, 10,000 over 5 plus 1245 e to the negative 0.97 times 2. And V, is it 3 or 5? 5. We're asking for 5. So 10,000 over 5 plus 1245 e to the negative 0.97 multiplied by 5. Now, what would you expect? Let's see. As t increases, right? Let's analyze. As t increases, this quantity becomes more and more negative, which means this quantity becomes smaller and this quantity becomes smaller. So the denominator becomes smaller. When you divide something by a small number, you get a large number. So the number of infected people are increasing. However, they cannot increase indefinitely, right? There's only 10,000 people. So after it reaches a certain value, it cannot increase anymore, which gives you the notion of there being a horizontal asymptote. Okay, and you can find that horizontal asymptote by seeing what happens as t goes to infinity. As t goes to infinity, this becomes 0, so you're left with 2,000 people. So at max, you have 2,000 people who get infected. Let's look at one last example. Now, usually, because we don't want to, worry about different kinds of compounding of daily and monthly and all of that, and we also know that if we let n go to infinity, we get the number e. So what is actually used when we do compound interest is continuous compounding. So in that case, the amount just becomes principal e raised to power rt, where r is the interest rate per year and t is the number of years. So if you look at our previous example, where we had $1,000, so PE at 12% to the power 3, which comes out to $1,433.33, which if you go up is not drastically different from some of the answers we had, right? 1433.24. So eventually it slows down after the daily, and then if you go to hour and seconds and minutes and milliseconds and so on, eventually you get to the e value for the 1 plus 1 over things, and this gives you an amount of 1433.33, and which would be also the maximum value that you can get, because it's you know you get the e when n goes to infinity, so it is the maximum value. So that's another application of these exponential functions, is they are used for continuous compounding. That's it for exponential functions. Since usually when we talk about functions, we also talk about or want to know about their inverses, the next thing we learned would be inverses of exponential functions. That's it for this video. Thank you.